Hello friends, welcome to Engineering Streamlined. Whenever we derive the heat conduction equation, we generally start by assuming an infinitesimal volume having dimensions dx, dy and dz. Then we balance the heat flux entering and exiting the infinitesimal volume in x direction followed by y direction and z direction and volumetric heat source. Today I will explain the idea behind the assumption of infinitesimal volume. A solid material at an atomic level consists of a fixed lattice structure. When heat is applied, these atoms start to vibrate from their equilibrium positions and cause lattice vibrations, which results in heat conduction. This lattice vibration in quantum mechanics is known as phonon, and the average distance that a phonon can travel before scattering is known as phonon mean free path. The phonon mean free path values are very small in the range of micro to nanometers. In a gas, when molecules gets heated, they rapidly move in different directions and collide with other gas molecules to transfer the heat energy. The average distance a molecule travels before a collision is known as mean free path. Mean free path of gas molecules is around 10 to the power minus 10 meters. If it takes say 10 collisions until a high kinetic energy molecule has a kinetic energy similar to that of surrounding molecules, then any external influence is not directly felt over a distance larger than 10 to the power minus 9 meters. If we consider the dimensions of a solid to be 1 millimeter in each direction, then 10 to the power minus 9 value is negligibly small compared to the overall dimensions of a solid, but very large in comparison with the mean free path for collision, and thus we can perform an energy balance on an infinitesimal volume. But the idea of infinitesimal volume is not applicable in case of thermal radiation. If we consider a surface which receives radiation from a point on the wall with vacuum surrounding, energy is transported in the form of photons traveling from source to the surface within the solid angle. In this case, the mean free path of photons is comparable to the dimensions of the geometry. If the surrounding medium is filled with a radiatively participating gas like carbon dioxide, its molecules will continuously absorb and emit radiation. In such a case, the mean free path of photons is very small, tending to 10 to the power minus 10 meters, and comparable to the distance between the molecules. Finally, if we consider the radiation coming from the sun to Earth's surface, the mean free path of photons will be very large, tending to 10 to the power 11 meters. Thus, conservation of energy cannot be applied over an infinitesimal volume, but must be applied over the entire volume under consideration. I hope you like this explanation. Kindly like and subscribe and keep looking for more videos.